Continue, ma'am.
A very delightful afternoon to all the worthy dignitaries, respected speaker of today's session, and delegates across the globe present over here. I, Ms. Deepika Rani Sahu, on behalf of entire organizing committee, again welcome you all to the third session of online FDP program on artificial intelligence in drug development, recent trends and future perspectives, sponsored by AICTE ATAL New Delhi and organized by Roland Institute of Pharmaceutical Sciences, Odisha. Here we have a great dynamic resource person with us. He is Mr. Syed Yasin sir with us, who is not only a researcher but also an inventor, mentor, and entrepreneur. Welcome you, sir, and thank you for gracing this afternoon with your presence today. Sir is going to Sir is going to be delivered a lecture on the essence of artificial intelligence and its applications in healthcare. Before inviting him, I feel privileged for taking this opportunity to reveal the biography of Sir among all of us. Currently, Sir is the Chief Scientist in Artificial Intelligence and Machine Learning at Safed Software Solution, Karnataka. He is also the founder and director at Bukle Innovations Private Limited, Bangalore, India. His passion in research has been started from childhood, and he began with his passion actively while he was in his engineering. He was invented an instant money counting machine that reduced the cost of money counting machine in the year of 1997 when he was only 23 and a computer engineering student. This innovation was continued by another significant innovation in the year of 2003 when he designed an algorithm that worked with speech engines to produce a system that would listen to voice commands and carry out orders like Alexa today. From this, the idea to draft algorithms on advanced machine learning techniques was born in his mind. His innovations were published in various reputed news leaflets like Times of India, Deccan Herald, Deccan Chronicle, etc. Ever since 1997, Sir has been working on various fields of high research interest like smart books and high-level security systems besides artificial intelligence. His area of expertise and interest lies in algorithms that would power the intelligence component in the next generation of machines, uh, and his vision in the near future is to influence search engines, robotics, and medical science. Sir has currently taken an entrepreneurial route and has been actively involved in trying to solve the knowledge element problem of World Wide Web and enterprise. Sir has filed two US patents consecutively in the year of 2007 and 2011 concerning in the field of artificial intelligence. Apart from this, two Indian patents also pending to be filed. His testimonials are he was a gold medal winner in Department of Science and Technology, DST, Lockheed Martin Innovation Growth Program for 2009. He is a winner of Outstanding Innovation Award that came from a Misted Media Private Limited, which focuses on business and economy in November 2013. With this grand biography, may I now request Sir to come on board and start the lecture. Over to you, sir.
Thank you so much for the introduction, and I really appreciate your help. Thank you once again. So in this particular session, let me take you through some of the advancements that have happened in the healthcare in particular. With respect to machine learning, there are a lot of exponential growth that has happened in various domains, for that matter. Image processing being one of the highly demand area. Apart from that, there has been a huge and significant development in natural language processing. And since both image processing and natural language processing have been more like saturated areas, then these both can actually be fused to basically cater to healthcare sector, wherein a machine can actually scan images and understand them, where a machine can actually read a health document and understand them. So these are the things which a machine can do. What a machine can actually do with respect to AI is you give the data for a machine The machine will learn from the data, and then based on the learnings, it can then identify those patterns when you give, some unseen data, new data to the machine. So let me basically demonstrate to you some of the things that a machine can do so that you can relate this to a pharmaceutical industry. Specifically, I don't have any specific demo with respect to pharmaceutical, unfortunately, but I can present some of the healthcare demos where drug-related information is actually highlighted automatically by a machine, where a machine understands that given a disease, these are the drugs that are actually related and are actually what you call uh, uh, reliable for that particular diagnosis or disease. So we'll run through some of the differential diagnosis, one of the applications that I have planned to give a demo today. Before that, let me take you through, you know we'll go with a demo, starting with what a machine can do, and then where we are progressing with respect to artificial intelligence. Currently, AI is progressing towards something called AGI, artificial general intelligence. That is the next big thing in AI. So AI is more like getting obsolete. Just AI, it's more like artificial general intelligence, which is the next big thing, wherein machines will also be dealing with something called logic, which is very, very complex for a machine to comprehend. But that is the plan that people have, people who are doing research in this field to get there.
Sir, excuse me,
Open
sir.
AI. Uh-huh.
Sir, make it full screen, sir.
Okay. You want me to make full? Actually, I'll be jumping through the demos and the screen. So let me blow this up a bit.
Noise.
Yeah,
Okay,
I
continue.
have to back and forth. I'll be doing demos, so you probably would want to see that. So I'll start with a demo where
Yes.
a machine will be able to recognize pictures. You see this cute baby here? Can a machine recognize objects, uh, given that it's trained to identify objects? So I have a bunch of pictures here. If you can see my screen, I have some kids riding bicycles. I have various pictures. So can a machine identify what this picture is like? We are educated on identifying these objects or pictures, that we know that this is a horse because we are taught as a child we used to learn that this is a horse, and this is a dog, and this is a sheep. Can a machine also do something similar to what we have been through, uh, like identify what this specific object is? If it is trained that this is a boat, identify that this is a boat. Remember, for a machine, this picture is nothing but a bunch of numbers that represent the pixel value. Pixel is a minuscule unit of what you call your image. So every pixel will have a value. For a machine, it's just a bunch of numbers. But using a pattern analysis, can machines identify these objects is a matter of concern. So let's go with example one. You see these two cars here. Can machine identify that particular object? I'm just giving that example here in this demo. I just have to write example underscore 01. So let's see if it identifies that. Oh, you see this? You see this yellow color box? It's called a bounding box, and it identified this as a car with 97.42% accuracy, and this as 99.93% accuracy. So when I say 99.93% accuracy, it obviously means that AI relies a lot on probability theory and statistics. So this is how machines see. You've heard about self-driving cars. This is how they see when your car drives on its own. These are the bounding box. In a self-driving car, the bounding boxes will be dynamic. They'll be dynamic. They'll be changing. In case we have more time, we'll show you how that actually works with respect to image recognition. If we have time, I can get back to that particular demo. Just remind me in the end. Just in case we have time, I can show you that as well, where you can easily understand that how an image is dynamically understood by a machine. So this is how a machine recognizes. Now let's go with some other examples wherein we have this example 5. We have a human being sitting on a horse, and we have a dog, we have a car. Can it identify multiple objects? Multiple different objects. This is example 5. You see here, it's 88% is this person. That's the accuracy it's showing, that it's able to identify this as a person with an accuracy of 88.44%. This is a horse with 99.91%. This dog is about 67 or so, but it is getting confused with two objects. This car is again 99.43. Now, these objects that you see, these are having certain threshold value, but if you see this, this image also has a background here. Probably this is a horse. It's not able to identify that. And again, a person standing behind, even this image is not identified. So there is a threshold value, which, probably, how do I put across, segmentation, or anyway, I'm not going to get too technical on this because I don't want to get you lost. But this is how a machine recognizes images, objects in images. So if a machine is trained to do a specific task, it can pretty much do that. That's the idea that I'm trying to put across. So now let's do some more demos. Now see, we have a, so let's do this. Let's try to give this as a image and see if this particular model. This model is based off convolutional neural network, if you've heard of it. It's pretty much used in object detection and image recognition. So it identifies this as a sheep with the 99.99% accuracy. And what about sheepdog? Confused. You see there, it's identifying that as a dog, which is actually correct. So it is identifying a sheep as a sheep and a dog as a dog. But just a second, will machines always work accurately? Actually, they don't. It depends on the training data that you have provided. And let me show you this horses too. So if you're using AI for any of your applications, be it pharmaceutical or healthcare, you have to be very careful when you're dealing with the training data, the data that is used to train a machine. So horses too, we are going with this image to see if an image, we saw it was able to identify a horse. So this is identified with 100% accuracy. So it's pretty accurate. But what about these horses one? You see a bunch of horses, you have a front view of those. Now it's a testing time for us to know if this particular model is being trained properly with all the dimensionality, of any object for that matter. So when I give horses one, it doesn't understand that this is a horse. You see, it's kind of messing up. It says it's a bird with 83.12%, person with 61.0, but we don't find anything like a horse here. So it's identifying everything except horse. So this is where AI fails. So this is a limitation of AI. So when you're training a machine with the data that you're, giving the algorithm or a machine to train with, you have to be super careful for what it is actually used for. So the end application is very important. So based off that, you provide the data, assuming or predicting that this will be your future inputs. So you have to take that into account as well when you're training a machine. So in this case, we clearly see that the machine is not able to identify horse's image if they are of a front view. So this about a little demo that I wanted to give you. Okay, this donkey too. Let me also show this. Whether it will confuse this to be a horse or a donkey. There's one more thing that I want you to understand is that if you're providing a data set for an machine or an algorithm to learn, you have to be super careful again to provide the same set of training sets with respect to all the data. Like you provide 100 images of donkeys, you also provide 100 images of horses. You don't provide like 100 images of horses and just 50 images of donkeys. So that will actually imbalance the network, and your weightages get a little scattered, and the output might get affected because of that. So in this case, let's see if it's able to identify a donkey and a horse, because they kind of look similar. So let's see if a machine is able. I mean, we as humans can identify that it's a donkey, but for a machine, it's pretty difficult. So in the case of sheepdog and dog, a sheepdog and a sheep, it was able to recognize. But so here, in case of this particular donkey, it's kind of messing up again. It says it's cow and it says it's horse, but it's not able to identify a donkey. So I'm not sure if this machine is actually trained to identify a donkey at all. So that's bad. So these are the limitations of AI. I may end this with another example. Maybe this example too, if it's able to identify a airplane. Oh yeah, so it says airplane, 99.36% accurate. So this demo, I basically wanted you to understand that, if you train a machine with data, then it can identify various objects. These are random images that I've downloaded from the net to basically test this model. You can pretty much give other images as well for it to basically identify. This is called a SSD model, single shot detector. So give a single shot of image, single image, and it'll identify objects of interest within that particular image. So in a nutshell, I'm going back to my slide. Machine can identify images. This is how machines see. We'll look into a bit of natural language processing. Can machine understand documents? Can they read documents? Can they actually speak? They actually can speak. You actually have your handheld devices, your smartphones, wherein you can talk to Siri. If you're using an iPhone, if you're using Android devices, you can pretty much talk to Google Assistant, where a machine can talk back. So they can understand what you speak, and they can actually talk back as well. So that's one of the areas of which has more natural way of communication with human beings. So you might be interested to have a look at it. But otherwise, let's see if a machine can identify or learn from documents. So before that, let me take you through a small classification by human beings. So this is how a human learns. Like if you are teaching a child, we basically show him a bunch of images of vegetable and say that these are the vegetables, and then we tell him that these are fruits, and then we teach him that these are toys, and then we ask him to separate vegetables, fruits, and toys. So what the child is doing is he's actually classifying this data. Assume that this is the data, and this is how a human by intelligence learns and gains knowledge. And knowledge comes from learning, of course, and learning comes with respect to guidance given by a teacher or parents. And then once a human understands that these are toys, these are fruits, and these are vegetables, this is how it kind of classifies. So let's reverse engineer this logic or philosophy of how we learn things and implement that in machines. So I'm going to show you an algorithm. It's called latent metanymical analysis indexing. This is an advanced machine learning algorithm. Talk about, let me touch upon what advanced machine learning algorithm is in a bit later. There are various ways of making a machine learn. The previous demo that I showed you with respect to identifying images, there you have to train the machine by giving respective images to identify in the future. If some similar image comes, the machine will identify that. But there are some algorithms that will learn from the data itself. You don't have to basically give any training data to them. They learn on their own. Now that looks a little difficult to understand or comprehend. But yes, technology is advanced to an extent that, you know, we as human beings can write mathematical formulations that will enable machines to learn on their own by decomposing the data. So this is one of those algorithms that learn from the data itself. So if you give this algorithm a bunch of documents, uh, not physical documents, it is digital documents. So in this example of just putting documents for a decent understanding. So you're giving documents on vegetables, on fruits, on toys. And if you give this documents to this algorithm, then it has an inbuilt intelligence, which is nothing but a mathematical formulation, and it is learned from the data itself. It is basically designed or formulated in a way that it decomposes this data of documents that is there in the documents, and then will create incremental clusters of contextually related terms. Like for vegetables, it can probably find irrigation farming, vitamins, manure. For fruits, it can find, food supplements, vitamins. For toys, it can find. So these topics are keywords it can find on its own. Then you add a new document on fruits, then it basically can incrementally index, find juice and oxidants, and then can classify in a respective bucket. In this case, it's a basket of fruits. So it can add those incrementally. So it can add any new data coming in, and you add a new, what you call object or a document on a new topic like animal. It can create a new cluster, in this case, a new basket, and add tiger and dog. So this is how a machine classification with respect to natural language processing kind of works. So I thought this might give you an idea of how NLP works. I'll show you some of the demos now with respect to NLP. We are here, we're trying to understand if a machine can understand documents and web content. Let me take you to MedBoom. So this is an advanced form of a demo. We don't have this feature even in Google, but this is the future of how search engines will work. Like I type in heart attack in Google. Again, Google is based off natural language processing. See, in Google, you get an overview of what heart attack is and some question and answers by people and some information links. And then you have related searches. Now, these are important. These are the related searches with respect to heart attack. So this is what Google gives. I'm going to show you what MedBoom does. MedBoom is a health-related web search engine. It's a pre-alpha. It's a prototype built on my algorithms. So when we give a heart attack query, MedBoom, you can see it brings overview definitions here. It's more knowledge-centric. So this is the knowledge element of the World Wide Web that we were talking about when I was introduced. So these are some of the question and answers which you also find in Google, but this is like how is the condition diagnosed, more specific to heart attack. And then you have symptoms, which you can actually see from here. You also have web results like Google Google does. I'm not comparing this with Google. I'm just giving an idea of where the future of search engine is actually progressing. It's pretty much progressing towards knowledge. So we don't have much of information. You have much of information here, information links, but this will be replaced in the future with more like knowledge elements. Like here you have that information link, but you click on this, you find an auto summarization of that particular content page, where you can actually read the summary pretty much from here. And then these topics that I was talking about was related searches. Now, if I have to find, just need to click one of these to go do a search on heart attack symptoms. But here, you see, pretty different. You don't get topics like this, related topics. I have my refined search here as well, where you find symptoms and first aid, and that is all fine, which is there. These are pretty much within the topic of heart attack. But outside of topic which are related with heart attack, closely related, is you can't even call it outside, because these are very much related to heart attack, are these. Now these are found by this machine or algorithm automatically, like I showed you in my previous slide, where a machine will learn from documents and classify the information contained in a document in the form of clusters, where those baskets were holding a couple of keywords. So this algorithm does that automatically. We don't need to train this. The algorithm scans through the web pages and extracts these topics or keywords, contextually maps them, decomposes the other information, and then creates contextual clusters. And it identified that for heart attack, these are the topics that are actually related. You see, these are the topics that are actually related. Now, one may find intriguing that how is acute coronary syndrome related with heart attack? If we are not doctors, we'd probably be interested in that. This is where the entirety of knowledge is represented in a second dimensional concept space, where I can just click that, how are these related, and it brings us acute coronary syndrome. This is what I was interested in, and it brings in here, which maps this information. Acute coronary syndrome is a term used for any condition brought on by sudden reduced flow to the heart. Now you see, so it saves time. So in case of this, to know acute coronary syndrome, it's almost impossible. With the typical search that we see today, we know we're going to land up to understand what acute coronary syndrome is or what cardiogenic shock is. So the future of search, or any application that you see on the web which is related to information retrieval, will be pretty much knowledge oriented. So give this to kids who are learning in colleges. It'll be so easy for them to find information within a few clicks. So I know that ibuprofen is a drug, ketoprofen probably is a drug, and you see, these are all related with heart attack. It's so easy to find the entirety of a topic. And it also gives drug information. Probably you might be interested in this because you come from pharmaceutical background. So it says that Prospective and Ramipril, these are the drugs for heart attack, and you can actually read more about it, and you can page it through, atenolol, warfarin. There's some of the drugs which are pretty typically given to people suffering from heart attack. Okay, which you can actually read from here. So you see how an algorithm is trying to map drug information with heart attack, overview definition, symptoms, and then related topics. This is all done by a machine automatically, reading through the documents. So this is what AI can actually do. So that is what I was talking about natural language processing. And then you have speech, which a machine can communicate, which I just mentioned. You can use your smartphones. I don't need to give a demo for that, because we use that almost every day. People are used to using a Google Assistant. They know how the benefits of it and the disadvantage of using it, because there are shortcomings at this point of time. So add this all together. A machine can see, a machine can understand documents, a machine can talk and hear. It's pretty much doing at some level what a human can do to a certain extent, not exactly like human, but it it is trying to mimic. So we are now getting into a formal definition of what AI is by, the father of AI, John McCarthy. He says it's a science of engineering of making intelligent machines, especially intelligent computer programs. Now, you put all these three things together, what do you get? You get this. This is what we're heading towards. We have robots right now. Boston Dynamics is one of the manufacturers in robotics, and it has developed phenomenal robots. But those robots can run, jump, do all the stuff that a human gymnast can probably do, and probably can do better because it is trained to do that. Now, what that robot lacks is logical intelligence, which we humans have. And it's an amazing, what you call blessing, from Almighty to us. Now these machines, they lack logic. Now this is where I was, bringing this word called AGI, artificial general intelligence. So if you bring in AGI and you combine these three things together and put logic into it, then you can actually write operating systems for robots that can learn specific things, or can actually the software can be downloaded from the cloud. So if a robot if you want a robot that can do surveillance, you download surveillance software from the cloud, like how you download what you call apps from Play Store or iOS App Store. So you can pretty much do that with respect to robots. So once you have an operating system for a robot to run application softwares of various segments, it could be used in healthcare. Probably a robot can act as a nurse. And of course, it could only complement. It can definitely not replace human beings. So don't mistake me that I'm talking about that these robots will actually replace human beings. They will not replace human beings, but rather they will complement the efforts of human expertise. That's the idea. So don't get it wrong. So this is the AI tree. I thought this might be important for you to basically know a little bit of AI with high-level AI, where you have various ways where this is machine learning. You have deep learning, which is pretty much boom in the past couple of years, and even today. And unsupervised machine learning is what I spoke about when I mentioned advanced machine learning. It is also called as unsupervised machine learning. And then supervised machine learning is where I showed you the first demo where a machine was able to identify objects from images. So that was supervised. The second demo when I gave about MedBoon was unsupervised machine learning and deep learning actually. And then we spoke about natural language processing. And expert system is where AI all started with. This was the first thing to come out way back in 70s and 80s. These were pretty much used in many places. Then we have speech. We spoke about speech, that you can use your phones where a machine can talk back and understand speech. We have vision. We saw a demo. The first demo was on vision, image recognition, machine vision. Planning, a machine can actually plan. I worked on one of the projects where a machine could actually go through the patterns of human planners, understand their patterns of how they've planned, and use those patterns back to plan for future projects relevant to supply chain management. In supply chain management, this demand supply planning has to be done. And human experts basically take, you have to, the human expert is pretty much trained. It's pretty complex planning where you have to use a lot of optimization techniques, and getting a real good plan would save a lot of money to the company. So this is where artificial intelligence comes in with respect to planning, where it kind of helps the planner plan better, because it pretty much does the groundwork for him with respect to statistical analysis, brings in those numbers to him, and then projects that this could be the future plan, and probably the planner can then tweak the plan and make it even more refined. So that's the idea. So yes, in planning, artificial intelligence is used. Robotics, I just spoke about Boston Dynamics. it's also pretty much there. You have self-driving cars. You have that could come probably in robotics as well. So AI in its true sense is about vision, speech, natural language processing, and logic. This is where I was talking about AGI, artificial general intelligence. So is AI glorified statistics? It is glorified statistics because you need a lot of training data for a machine to start learning and then predict the outcome. So what I'm going to show you now is some of the artifacts relevant to probably a drug, but not exactly. Maybe you could get some idea where do another application trying to connect to pharmaceutical, how this can be done. So I have my chest pain and let me take a drug and say, I don't know if any drug will come here. Yeah, you see here, aspirin used for pain management, for weakness, acute pain management. So this is drug, and you have a bunch of results on drug. This is taken from books, and then acute coronary syndrome. So probably this might be of interest. It's also used for chest pain, delirium, and dementia. Okay, so this is probably some of the side effects. Yeah, side effects are here. See, it's kind of clustering the relevant terms, and it's bringing the relevant information with respect to that particular drug. So drug to drug interaction is another interesting field which you might be interested in, pharmaceuticals, where of course it's a concern for doctors to understand drug to drug interaction, because you cannot give two drugs sometimes together. That might cause poisoning and be fatal for the patient. So there are many ways in which AI can actually could be of pretty much help with respect to these things. So this is one aspect of what I was trying to show, just in case you give something like drug information, and the clinical presentation for aspirin could be this. It brings that relevant information here. So the one more thing going forward is this differential diagnosis engine. This might be relevant for pharmaceutical industries. Instead of chief complaints, you give a bunch of drugs and you know relevant information about those drugs, and probably you can get something like what you're going to see now. I will select chief complaint as abdominal pain. This is a differential diagnosis engine wherein assume that a patient has come with abdominal pain, and an AI algorithm is trying to diagnose what could be the ailment. So here it brings up a bunch of symptoms and signs relevant with abdominal pain. So I will randomly select a few symptoms like abdominal distension, bloating, diarrhea, and your signs could be fever. Okay, so I've just selected 4, and then once you submit these symptoms and signs, let's see what this AI comes up with. It says gastroenteritis could be 39%. Diverticulitis could be 31%. So do something with respect to pharmaceutical industries in this context, and probably you could, in your research, you could probably apply this algorithm in a certain way by tweaking a few parameters, and probably this could be of some use to you. Because so you think about it. I'm just trying to give you an idea of where AI can be used. Unfortunately, I don't have any specific use case for pharmaceutical industries where I can actually present you something more relevant. But this is the closest I could get. So here, It says diverticulitis and gastroenteritis. These are close, wherein we see that a nurse can or a doctor can re-examine the patient and say if he's having symptoms. These symptoms are signs. You can ask if he's having nausea and vomiting. If you can with diverticulitis and say if there is constipation. So, so probably he finds heme-positive stools and constipation as a symptom. This act constipation. That constipation as a symptom and heme-positive stool is what he finds after re-examining the patient. So when you submit again, you see diverticulitis comes up. It was at second number before. Now this comes up. So the probability kind of grows more. So then probably he re-examines and finds there is also rectal bleeding. The patient didn't mention it before, and the probability still goes up, 61%. So this is dynamic. This is something which IBM has done in a much advanced manner using IBM Watson supercomputer, where a machine can actually diagnose cancer. It was been empirically tested in some of the hospitals a few years back, but I was told that it was not a very huge success, though. Uh, Definitely, a machine cannot replace a human expert like a doctor, but what it can do is it can help complement a human expert like a calculator. I mean, we need calculators. It doesn't mean that calculator replace human beings, but what calculators do is they increase the efficiency of human beings by saving that much of time. So similarly with using AI in pharmaceutical industry or healthcare, it doesn't replace a human expert. So that is a misconception. A machine can never replace a human expert. What it can do is it can increase the efficiency of that human expert by bringing in these statistical information that can help a human expert re-exam or rethink about some of the things that he might have not thought of earlier. So that's the idea. That's the idea of how AI should be seen. Uh, of course, there is a threat on with respect to AI because we still have AI not regulated. AI is still not regulated, so we need to have AI regulated. So that's pretty important going forward. So I think these were the couple of demos that I wanted to show you. Uh, Probably this could give a better idea of you know how things can be done with respect to AI use in the pharmaceutical or healthcare sector. So wherein I happen to work on one of the projects where algorithm or a machine was learning practice patterns of doctors and taking those patterns into consideration. It was then kind of trying to audit how the nurses were performing. The nurses were giving a wrong drug. So there's drugs given to patients just in case it was a minor ailment like a cough or a cold, to see if that drug was given appropriately. So that was basically learned by this algorithm based on the doctor's prescriptions and then mapped to if the nurses are giving something similar or something totally, uh, you know, outside of the nature of drug that is supposed to be given to that particular disease. So that was also done in one of the works that I had worked on for one of the companies where the nurse was trying to the machine was trying to kind of audit the nurse to see if the practice was nice, just in case if there is some discrepancy, so that it kind of alerts a respective doctor to see that the patient doesn't take that particular drug. So that was the idea. It was not like to audit a nurse or something like that, but it was to help the entire ecosystem of healthcare in itself. And that is very sensitive because people are very sensitive with respect to healthcare. If they get to know that a machine is kind of diagnosing them, they may not like it. Pharmaceutical industry is a little different, wherein you don't have direct interactions with the end user. It's rather that you're trying to build a new medicine, and that might take a lot of time. I mean, I heard that it takes like 10 years of what you call testing and after development until a drug is released. So that's a huge investment that goes with respect to releasing a drug to the world. But in the meantime, if AI can help in pharmaceutical industry to come up with better testing of a drug and giving some statistical analysis with respect to how this is behaving in the field, then probably it may make more sense. So I think this is pretty much about what I had to put across with respect to healthcare. I do have other slides explaining neural networks and reinforcement learning, but we're going to get deep into AI, which you might not be pretty much interested in. So this goes on with respect to the math involved and how things are. So let's not get into that part. Let's just stay focused on how AI could be used with respect to helping the healthcare fraternity, and you can map some of the demos that I showed you to how it could actually help with respect to pharmaceutical companies. So this is how far I can go with respect to the demos. You have any specific questions that you might want me to answer?
No, sir, I have not received any questions in chat box.
You can okay, you can put your questions in the chat box. I'll try to answer them
Yes,
if
sir,
I
yes.
can.
Yes, sir.
But were those demos relevant? Were they able to help you understand how AI could actually, because I didn't have any demo with respect to pharmaceutical industry, so all I could do was try to map it with health and see how you can relate that to pharmaceutical industry.
Okay, like this it is okay, sir. But you are telling it is useful.
Thank you. I
Yes,
am
sir.
glad that it helped a bit.
Yes, sir. Yes.
Any specific questions? Because pharmaceutical industry is one of the most booming industries. I happen to also talk to one of the companies. Have you heard of IMS Health, Quintil's IMS? It was merged with Quintil's recently, and it's called IQVIA, one of the leading biopharmaceutical companies. They gather a lot of data from various pharmacies and collate them and then sell it to biopharmaceutical companies. It's not directly a pharmaceutical company, but they kind of sell data to pharmaceutical companies. IQVIA, they do a lot of statistical analysis with respect to drug information. What are the kind of drugs that were given to various patients across the geographies? Like in Bangalore, what is the most common drug that is being sold? They sell that kind of data to pharmaceutical companies so that they plan their manufacturing accordingly. It's all got to do with the AI and statistics. So let me know if you have any specific question with respect to pharmaceutical companies. I wanted to keep this slideshow short because I thought let me answer any specific question that you have with respect to pharmaceutical companies so that I could help you bridge the gap between where AI can actually help in pharmaceutical industry.
Sir, can we apply in a manufacturing of any pharmaceutical products so the manufacturing level can be increased?
Yes. That is exactly what this company called IQVIA does. What they do is they basically give a software to most of the pharmaceutical outlets, like a pharmacy. They give their software, and they give the software for free. That is what I heard. And that software will help this pharmaceutical what you call outlets manage their back office and sales, but in exchange of data. So the data they get is what was the most drugs sold in a particular location. So they have the most sold drug information for that particular geography. In case of Bangalore, they would get like top 5 drugs sold in Bangalore, and then top 5 drugs sold in Odisha, probably top 5 drugs sold in Delhi. So based off this, they will have a lot of statistical information about what drug for a given geography is sold on statistical analysis. And then they have a predictive analytics where the software can an algorithm can actually predict that going forward in 6 months this will be the demand for this particular months in these geographies for these particular drugs, so that the manufacturing the demand and supply is coherent, they are mapped together, so that the optimization is taken care of, so that you don't produce this drug in excess or you don't underproduce it, so that there is a demand there outside. So that is one of the use cases where you can use statistical analysis, but the statistical analysis used here is pretty simple. It's not like very complex. You just need to work through predictive analytics. So that is not like a very complex model. It's a very simple model, but it is very much important. I hope that answers your question.
Yes, sir. Yes, sir. We have received this question on chat box.
Can you tell us the search engine for writing AI algorithm? Uh, okay, you want to write an AI algorithm on? I didn't understand that question. Can you tell us the search engine? Search engine. I
The
didn't understand this
participant
question,
cannot
which is posted by
directly.
Rekha Vasudeva.
Yes, sir.
Yeah. See, if you want to write an AI algorithm, one needs to have understand the problem that you have, that you want to actually solve, and then gather the statistics for solving that problem. Then you have to mathematically formulate that problem and solve it so that a machine can actually do that. And for doing that, one needs to basically have a decent understanding of linear algebra, nonlinear algebra, calculus, matrices, statistics, probability theory. This will actually help one formulate that problem mathematically. And once you've done that mathematically, it's just a matter of writing an algorithm to solve that particular problem, and then you have an algorithm ready. So it's not that simple though. I just took a couple of seconds to mention that, but it takes a lot of years to basically understand, comprehend, to basically be able to apply that in real world. But again, if other people are doing, you can definitely write an algorithm. It's not like rocket science. What are the methods to treat raw data before good for processing? So you have something called ETL, and enterprise transform load. I'm not sure I'm getting that right. So it's ETL is a process where so get through a sanitization process of the data, and you also call that as flattening the data. So your extract transform load will basically be one of the data pre-processing step in your data warehouse. Uh, so once you've cleansed the data, and then it's ready for getting into data analytics. So that is when you start statistical processing. But before statistical processing of the data, you cleanse the data. So ETL is one of the main areas where the raw data is kind of treated. Sir, what is the status in India regarding uses of robotics in hospital? As per my knowledge, AI is used in hospitals of foreign countries. See, the status of robotics in hospitals is still very naive. Uh, it's not like people are kind of willing to talk to a robot. It's only the next generation will be more used to talking to machines, because we see kids always on phones today. So they may be more uh, receptive to advanced technologies that will incorporate robots. So definitely the older generation of today will definitely not like to talk to a machine. So that is another uh, what you call constraint. And also the technology that we have with respect to applying uh, you know healthcare specific tools into robotics is not very much saturated to an extent where it's not like rigorously tested. There are some use cases. They are doing some trial and error kind of what you call empirical analysis in hospitals. I have seen during COVID there was this robots in some of the hospitals that was doing this testing of temperature and then allowing people inside. So that is all fine. But to an extent where it can actually or actively help a nurse or a doctor, it's still a long way to go. So it's going to take a while. Robotics with respect to surgery is there already. With respect to endoscopy and other stuff, it's pretty much there. But with respect to human-to-human interaction, there is not much of what you call use cases that I have actually seen through or experienced through along my journey. So I do have a limited knowledge around this. If robots will be relevant with respect to hospitals, uh, I'm not very sure, because as a human patient, he may not like a robot to treat him or to take care of him. He may probably like a human expert to take care of him. Where robotics is actually used is you may be willing to see this called. There is a company in Japan called Cyberdyne Systems. Go through this company. They build exoskeletons wherein a human can actually wear. Let me, if you're able to see my screen, you can actually see this. Japan. There's a company in Japan. Yeah. So these guys, they make exoskeletons, and they basically are catering to um, products for see this limb support, single joint, lumbar type. You see this, you visit this website, and this basically are robots that a human can actually wear them. They're called exoskeletons, and then they're used in healthcare. You see this, this robots can help a patient actually walk. There are so many and also it's used in manufacturing industries where humans have to lift a lot of loads, and also hospitals where a nurse can actually pick up a patient easily, because using this exoskeletons device, you can actually lift more weight. So that's the idea. See, this grandma probably is not able to walk, and then she would need some kind of an exoskeleton that will help her walk easily and do her routine easily. So you probably could go here and work on this. This is a very advanced technology. There's been a lot of research that has been gone into this. The inventor of this company, I mean, these devices was a professor in one of the institutes, and he came up with this, invention sometime back. But this is this is a huge leap in AI. Have a look at this work. Probably that would help you. Okay, so that is the status with respect to robotics in hospitals. So is there any book or website to learn writing algorithm? You can start with mm, how do I, if you're willing to write an algorithm, you start with this, typical math, which you actually have been through in your 10th grade and your 12th grade. If you've taken maths in your 12th grade, just revise that, and then you you can go through a book called again, neural networks is one of the areas of AI, but neural networks doesn't cover entire AI. You can probably go through this book called uh, Artificial Intelligence by Rashid. AI book by Rashid. He's written a very simple book on neural networks. Okay, Tariq Rashid. Yeah, you can buy this. Make your own neural network by Tariq Rashid. You can go with this book. It's a little cheap on Kindle, so you can go with this book. But it's very simple, easy to understand. This person covers a little bit of basic math as well, so you might want to have a look at it. And the other question was how to write AI algorithm. Uh, okay. The first thing when you start with an algorithm is to identify the problem that you want to solve and that you want the machine to solve, and then write the steps like how a human can actually solve it. Okay, once you've done that, gather the information that requires a human expert to solve that. So probably you need a bunch of data. So once you've done that analysis, then try to formulate if a machine has to solve this like how human will solve, then what are the mathematical or statistical analysis that are needed for a machine to actually solve it. That takes a lot of time, by the way. That's how you start writing an algorithm. And to write an algorithm mathematically, again, I have to emphasize that you have to understand these, mathematical concepts a little bit in depth, so that your mathematical formulation becomes easier. So that's how you basically start writing an algorithm. So once you've written an algorithm, you take the mathematical formulation or logic and implement that into a Python code or a Java code, whichever technology you want to use, you can use, and then you write a software that can execute and give you the results. That's exactly what I showed when I was showing this particular demo. There's a command prompt that calls a program that is designed to detect an object of interest in an image. So it's an image processing program that has this algorithm implemented, and then that's how a machine is able to identify objects. Okay, yes, sir. In Japan, these are used. Yes, it's used in Japan, and that's a very fascinating technology. So these devices could be seen maybe in the future in India as well. That's what I presume. But they're expensive, so I don't know how this will actually be. So there are many other what you call constraints that need to be taken care of, but it's just a matter of time. If it's used in Japan, there is definitely and these devices are pretty good. That's what I came to know based off my research. So any other questions that you might have? Was this session helpful in some way? The
Yes, sir.
feedback
Yes,
is
sir. Yes, sir. We will send you the feedback also. If any questions,
yeah,
we
that'll
can
help
clarify
me.
by that. Yes, sir. Yes.
Absolutely,
Thank you,
absolutely.
sir.
I'm
Thank
on
you, sir, once again.
Same here. It's my pleasure. I'm on LinkedIn. You can connect me on LinkedIn,
Yes,
and
sir.
in case you have any questions, you can post me there as well. I usually reply. Thank you so much. Any other
Thank you.
thing that you want to ask? We have like 15 minutes more, I guess.
No, sir, nobody. I think you have cleared all these doubts in your presentation.
Thank you.
Yes.
I hope
Now you
I
proceed.
hope I did it.
Uh, th- Thank you so much, sir, for
So
your
have a very
insightful
nice day,
presentation.
and
sir, disconnected. Just a second. Deepika ma'am, you can proceed.
Yes, sir. Thank you so much, sir, for your insightful presentation and sharing your valuable knowledge with us. It's really a wonderful live interactive session with you, sir. And we are
Thank you.
really delighted for your presence today, sir. Thank you so much.
Thank you.
Now,
Thank you so much.
now I request to our beloved Vice Principal and co-convener of today's program, Dr. C.H. Niranjan Patra, sir, to present an e-certificate of appreciation to Mr. Syed Yassin, sir, as a token of love and admiration on behalf of entire Roland family.
Thank you. Thank you so much.
Just a second. Sir, please accept this e-certificate as a token of love and affections. Please, sir.
Thank you. Thank you so much, sir. I really appreciate this courteous souvenir from your side. I really appreciate it. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. Thank you. Bye.
Madam, continue.
Yes, sir. Due to norms and regulations as per AICTE, all the participants are requested to join the yoga class for the requirement of today's pandemic situation, which held after some time. I request all the participants to please join with us. Now,
Which second, another link.
yes, in another link that was already shared in your email IDs and WhatsApp groups. Thank you all.